Earlier, the size of semiconductors, or you can say the transistors specifically, ranged from a size of 5 to 30 micrometers, but nowadays it has been drastically reduced to a mere size of 5 nanometers. Now, if you ask me, this is a great deal of size reduction. Due to this, the number of chips, the number of transistors we can accommodate in a given chip has been increased to a few billions, which is great nonetheless. Good morning everyone, my name is Yashasvi Khare, and this was one crazy fact about transistors which still intrigues me the most to this day. As for myself, I would like to provide some basic insight of what I have covered. Right now I have covered a majority of projects in physical design such as PNR, such as STA, which is basically static timing analysis, and some routing. Now, before we dive into the tool, I would like to give you a basic idea of how the tool functions, what happens inside it, and what we require as a start. So let's do it. So before we begin, I would just like to give you a gist of what does the Innovus PNR tool do. Innovus PNR is basically a placement and round tool which is used to perform a multitude of physical design processes such as floor planning, power distribution, placement, CTS and routing. Moreover, it can also perform DRC analysis such as basically check for metal width, metal area and so on. Now, as we move on, let's move on to the main part of this presentation, which is inputs for the placement and route. Now, first input is the .v, which is the Verilog file. This Verilog file is the netlist that we claim it to be. It is a file which is responsible for the input and output port declarations. Whatever input declaration will provide and the output ports will provide is going to be specified in this particular file. It also defines the connectivity of the ports with the intermediate logic, how the output and the input is talking with the logic present inside of the particular, you can say, module. It also defines the logical connectivity of how the logics inside the particular module are talking with each other. So this was the Verilog, you can say, or the netlist file. Now we come to the STC file, which is also known as by the name of constraints file. This file has the necessary clock information and regarding its period. Now, if you have covered STA, you might have seen MCP, which is multi-cycle path. Here you must have seen HCP, which is half cycle path, also false path. Now these are basically the timing optimizations that we can apply in this particular file. Now let's move on to the next file, which is the .lib, also known as the library file. This file has the delays of each and every cell defined, whatever time it will take, how much time it will take to charge a certain amount of output cap at what input branch, everything is defined in this particular file. It also has the drive strength of every cell defined. Also, I would like to mention this as an extra point, that each and every cell may have multiple drive strengths. It also has area defined of the particular cell. Most of the information regarding the timing is provided in the form of LUTs. Here LUTs stand for lookup tables. These lookup tables are basically in the form of a matrix in which each information is provided by two indexes, index 1 and index 2. One of the index is the input trans and the other index is the output cap. Based on the combination of these two inputs, the output, or you can see the timing of the particular cell, is characterized. Now we move on to the .lef, which is the library exchange format. It is the file which has the information regarding the physical parameters of the cell, such as the cell name, pin size and orientation. It will also provide you the information that what logic gate, or you can say what logic cell is using which layer of routing. It also has information regarding different types of blockages used in the design. Now the techlef file, which is the last input for this particular PNR stage. It defines the units for metal layers and blockages. It defines various design rules depending on the technology. It also has the physical and electrical parameters of the layers and VRs. By electrical parameters, I mean the RC. By physical parameters, I mean the basic units which are provided by the foundry. Now here, I have opened the Innovus, and upon opening Innovus, first you have to go to the file, then go to the import design. After going to the import design, you will encounter something which will look like this, design import. Okay, now we are at the design import. What we have to do is that we have to input the netlist file. Now the netlist file is basically this one, DTMF RECVR code, which I have inputted from one of the folders which I have. And then as we have inputted this Verilog file, now it's time to move for the lib and left files. For the left files, we have to define all the left files we are going to use in a single go. That means when you are defining the left files, upon defining these left files, what you have to do is basically take all the macros that you actually have in your design plus all the normal left files. All of them should be defined in a single instant, and then we have to go for the power planning, which is basically the power nets should be defined here, VDD, the ground net should be defined here, VSS. Now we are not providing any file since we are working on a single power profile. Normally there can be multiple power profiles in a given chip. So for that you require another file which is basically an optional file, and that is known as the UPF, Unified Power Format. Here it is not required, so we are just inputting the power nets and the ground nets. Now it's time for the viewDefinition.tcl. Basically, this file has the information about the pass of the .lif file, which was one of the necessary inputs, and then it also has the information about the multi-mode and multi-corners, like which RC corners are being used to calculate these delays. I have loaded the design already, so you can see that already the design is loaded, and you have all the macros lined up and all the logical instances lined up. Now it's time for the placement. So that was all about my project, which was basically loading a design in Innovus. If you have any suggestions for me, please let me know in the comments down below.